The wrench slipped, blood on his knuckles, -40 degrees, and Sergeant Eddie Morrison was elbow-deep in the engine compartment of a Sherman tank doing something that could get him court-martialed. The governor. That little mechanical tattletale that kept the Ford GAA engine locked at 2600 RPM. He'd watched too many crews die because they couldn't outrun German 88mm guns. Watched Shermans bog down in mud while Panzers repositioned. The manual said removing the governor would void the warranty and violate Army regulations. The manual hadn't been written by someone watching their friends burn. His hands found the governor assembly. 3 bolts. That's all that stood between regulation and survival, between following orders and coming home alive. He looked at the men sleeping in their bedrolls 20 feet away. Every one of them trusted him to keep this 33-ton machine running. The choice wasn't really a choice at all. This is the story of how one sergeant's wrench changed battlefield doctrine. But it's really about what happens when the gap between what the manual says and what the war demands becomes a chasm filled with burning metal and dead tankers, and what it reveals about the eternal tension between institutional control and individual survival, between regulation and reality, between the war the generals planned and the war the mechanics had to win. July 1944. Normandy, France. 6 weeks after D-Day, and the Allied advance had stalled. Not because of German resistance, though that was fierce. Not because of supply lines, though those were stretched. The advance had stalled because of something no one in Washington or London had properly planned for. Hedgerows, the bocage, ancient earthen walls topped with centuries-old vegetation, crisscrossing the Norman countryside like a medieval maze designed specifically to murder tanks. Every field was a fortress. Every lane was a kill zone. When a Sherman tried to climb over a hedgerow, physics became the enemy. The nose tilted skyward, exposing the tank's soft underbelly, its thinnest armor directly to German anti-tank weapons. The main gun pointed uselessly at the clouds. The crew became a stationary target with a giant sign saying, "Shoot here." Dozens of Shermans were knocked out this way in the first weeks, not by superior German armor, not by tactical brilliance, by geometry and ancient agricultural practice. The official solution was to wait for engineers with explosives to blast holes through each hedgerow. This took time. It was loud. It told every German within a mile exactly where you were and what you were about to do. It turned offensive operations into a predictable rhythm. Blast, advance, blast, advance. The Germans learned the pattern and adjusted accordingly. Tank commanders were screaming for a better solution. Battalion commanders were demanding a better solution. But solutions don't emerge from staff meetings in clean uniforms. They emerge from the field, from the mud, from soldiers who refuse to die according to regulation. Sergeant Curtis Culin didn't look like a revolutionary. 29 years old, serving with the 102nd Cavalry Reconnaissance Squadron of the 2nd Armored Division. Before the war, he was a tank mechanic from Cranford, New Jersey. He understood machines. More importantly, he understood that every problem has a solution if you're willing to look at it from the right angle and ignore what everyone says can't be done. One evening, during a bull session about the hedgerow problem, a soldier named Roberts, a Tennessee hillbilly according to the accounts, said something that everyone laughed at. "Why don't we get some saw teeth and put them on the front of the tank and cut through these hedges?" The room erupted in laughter. Cullen didn't laugh. He heard something everyone else missed. A kernel of practical genius wrapped in country simplicity. The next morning, Cullen was at the beach looking at German obstacles. Czech hedgehogs, massive steel I-beams welded into vicious crosses, designed to rip the bottoms out of landing craft. Thousands of them littered the Normandy beaches. Thousands of tons of high-grade steel just sitting there. Within hours, he had a prototype. 4 steel prongs cut from hedgehog obstacles, angled forward, welded to an angle iron frame mounted on the front of his tank. It looked crude. It looked agricultural. It looked like something a farmer would cobble together in a barn. It worked perfectly. The tank hit the hedgerow at 10 miles per hour. The steel tusks bit into the earthen wall, held the tank's nose down, and the Sherman punched through like a freight train through a barn door. On the other side, a clear field. No exposure, no vulnerability, no dead crew. Word spread through the ranks like electricity. Lieutenant General Omar Bradley heard about it, and demanded a demonstration. Bradley was a careful man, a planner, not given to enthusiasm for untested field modifications. He watched Cullen's tank hit a hedgerow, watched it explode through in a cascade of dirt and shattered vegetation, watched a second tank duplicate the result. Bradley later wrote that he watched in awe. The commanding general of the First Army was in awe of a sergeant with a welding torch and scrap metal. Within 24 hours, Bradley ordered every ordnance unit in the Army on round-the-clock production. Every welder, every machine shop, every maintenance depot was mobilized to produce what became known as Cullen hedgerow cutters, or rhino tanks. They worked under camouflage netting, so German reconnaissance couldn't see what they were building. Within a week, 3 out of every 5 tanks in Operation Cobra, the breakout from Normandy, had been equipped with the device. This wasn't official doctrine filtering down from above. This wasn't the product of think tanks and proving grounds. This was a revolution from below. A sergeant with practical sense had solved in an afternoon what generals and engineers had failed to solve in weeks. Cullen was awarded the Legion of Merit. President Eisenhower would later tell the story on national television. A humble man, Cullen tried to give credit to Roberts, the hillbilly whose joke he'd taken seriously. History forgot Roberts. It remembered Cullen, but the real story isn't about individuals. It's about a pattern that would repeat itself across every theater of the war. American soldiers, confronted with problems the manual didn't cover, refusing to die according to someone else's rules. Now we need to understand something about the Sherman tank that's been obscured by decades of mythology and misunderstanding. The Sherman has a reputation. Decent tank, reliable, but outgunned and out-armored by German Panthers and Tigers, a death trap that only won through numbers. American industry's mass-produced consolation prize. This narrative is comfortable. It fits a story we want to believe about American pragmatism and German engineering excellence. It's also deeply incomplete. The Sherman wasn't one tank. It was a platform, a constantly evolving system produced in multiple variants with different engines, different transmissions, different armor packages, different weapons. Between 1942 and 1945, roughly 50,000 Shermans rolled off American production lines. That number alone tells you something. When you produce 50,000 of anything, you learn things, you iterate, you improve. The Sherman that landed in North Africa in 1942 and the Sherman that crossed the Rhine in 1945 were different machines. At the heart of many late-war Shermans was an engine that remains one of the most remarkable pieces of engineering to emerge from World War II. The Ford GAA, if you've never heard of it, that's because it's been eclipsed by more famous engines. The Rolls-Royce Merlin that powered Spitfires and P-51 Mustangs. The Wright Cyclone that powered B-17 bombers. But the Ford GAA deserves to stand alongside them. An 18-litre, all-aluminum, V8 with dual overhead cams, 4 valves per cylinder, and a flat-plane crankshaft. Features that wouldn't become common in automotive engines for another 50 years. This wasn't an adapted truck engine. This wasn't a repurposed tractor motor. This was a purpose-built power plant that happened to be so advanced that modern engineers look at the design and ask how Ford pulled this off in 1942. The GAA story begins with Henry Ford's ego and ends with one of the best tank engines of the war. In 1940, Ford was approached to manufacture Rolls-Royce Merlin engines for the British. Ford's engineers studied the Merlin and concluded they could do better. They designed a 27-litre V12 intended to outperform anything Rolls-Royce built. The Air Corps wasn't interested. Too much politics, too many existing contracts. The V12 sat unused. Then in 1941, the Army Tank Corps came calling. They needed engines for Sherman tanks. Lots of engines. The existing Wright R975 radial was adequate, but not stellar. Ford saw an opportunity. Take the V12 casting cores, remove 4 cylinders, and create a V8. The Ford GAA was born almost by accident. On paper, 500 horsepower at 2600 RPM. Torque numbers that looked like misprints. 1400 Newton-meters at idle. 950 foot-pounds throughout the power band. The engine didn't need to rev high. It lived at low RPM, producing sustained, crushing power. For a 33-ton tank slogging through mud, climbing hills, pushing through obstacles, this was perfect. But there was something else, something that made the GAA special in ways that went beyond the numbers. It was built like an aircraft engine, not a truck engine. Every component was secured with safety wire. Critical parts were pinned in place. The valve train was gear-driven, no belts or chains that could break. The magneto-ignition system was redundant, dual spark plugs per cylinder. This was an engine designed to run when everything else had failed. The M4A3 Sherman with the Ford GAA became the US Army's preferred variant, not the most produced. The Americans kept most of the GAA-powered Shermans for themselves. They sent M4A2s with diesel engines to the Soviets via Lend-Lease. They sent M4A4s with the Chrysler Multibank to the British. But the M4A3 with the Ford GAA stayed primarily with American units. There's a reason for that. In 1943, the Army conducted reliability trials. 10 Shermans, different variants, pushed to destruction. The M4A3s with Ford GAAs covered more than 20,000 combined miles, split between roads and cross-country, over 2,300 hours of runtime. When engines finally failed, they could be returned to service by replacing a single component. Maintenance was simpler than any other variant. Fuel economy was better. Performance in difficult terrain was superior. The Ford GAA wasn't just a good engine, it was the engine American tankers wanted under them when they went into combat. But the engine came with a governor, a mechanical device that limited RPM to 2,600. At this speed, the engine produced its rated power safely within design parameters. Run it higher and you risk damage, premature wear, potential failure. The governor was there for good reasons. Engines in military service need to last. They need to be reliable. You can't have tank crews hot-rodding their power plants and grenading transmissions in the middle of France. The Army didn't want field mechanics tinkering with precision machinery. But here's what the Army didn't account for. Tank warfare isn't predictable. Sometimes you need every ounce of power the machine can give you. Sometimes the difference between living and dying is whether you can accelerate out of an ambush or climb a slope fast enough to get hull down before the 88 finds you. Sometimes the manual gets men killed. Tank crews learned this quickly. In conversations after the war, veterans confirmed what was an open secret during it. Mechanics routinely removed the governors from Ford GAA engines. Not all of them, not officially, but enough that it became standard practice in units that had seen heavy combat. Without the governor, the GAA would rev to 3,800 RPM before valve float became an issue. At 2,800 RPM, the engine produced 525 horsepower, more acceleration, higher top speed, better performance on slopes. The engine could handle it. Ford had overbuilt the GAA using aircraft engineering standards. The connecting rods were forged steel. The crankshaft was machined to tolerances more appropriate for a racing engine than a tank. The cooling system had capacity to spare. Taking the governor off didn't break the engine. It unleashed what Ford had built into it all along. This created a fascinating dynamic. Officially, removing governors was prohibited. Unofficially, officers who understood the realities of combat looked the other way. Maintenance sergeants developed a sixth sense for when to document repairs and when to forget they'd seen anything. The mechanics who did the work operated in a grey zone between regulation and necessity, between following orders and keeping their crews alive. And here's where the ideological fault line appears. The Army as an institution believed in standardization, in uniform procedures, in equipment operating within specified parameters. This belief wasn't arbitrary. Logistics depends on predictability. Spare parts inventories are calculated based on expected wear rates. Training manuals assume standard configurations. The entire machine of modern warfare requires that a Sherman tank in Normandy operates identically to a Sherman tank in the Philippines. But the men actually fighting the war knew something the institution didn't want to acknowledge. War is chaos. Combat is improvisation. The enemy doesn't care what your manual says. Every time a mechanic removed a governor, he was making a calculation. The risk of discipline versus the risk of death. The possibility of damaging an engine versus the certainty of needing that extra power when German armor appeared. These weren't reckless kids hot-rodding for fun. These were experienced mechanics who'd seen what happened when Shermans couldn't maneuver fast enough, couldn't climb fast enough, couldn't retreat fast enough. They'd pulled burned crewmen from knocked-out tanks. They'd watched friends die because the book said 2,600 RPM was sufficient. The book was wrong. They fixed it with a wrench. Let's talk about the broader context. Because the governor issue was one small example of a much larger pattern, American soldiers in World War II had something the German military increasingly lacked as the war progressed: mechanical aptitude. The average American soldier in 1944 had grown up in a society increasingly defined by automobiles, tractors, radios, and consumer machinery. By the 1940s, most American families in urban areas owned cars. Rural families operated farm equipment that required maintenance and repair. American boys learned to work with tools, to diagnose mechanical problems, to improvise solutions, because calling a specialist wasn't always an option. This created a military force with a collective mechanical intuition that proved invaluable in the field. German soldiers, by contrast, came from a society where cars were still luxury items, where mechanization was less pervasive, where the average citizen had less hands-on experience with engines and machinery. The German military compensated with technical schools and specialized training, but there's a difference between taught knowledge and lived experience. When something broke in the field, American soldiers were more likely to have the background to rig a solution. When something needed to be modified, they had the confidence to try. This wasn't about intelligence, it was about exposure. It was about growing up in a culture that democratized technology rather than reserving it for specialists. Look at the modifications American units made to their equipment. The Cullen hedgerow cutter is famous, but it was just one example. Tank crews welded extra armor plates salvaged from destroyed vehicles onto their Shermans, creating makeshift up-armored variants. They sandbagged hulls despite official warnings that it didn't help and added weight. Whether it actually worked is debatable, but the impulse to do something rather than accept vulnerability drove constant experimentation. They mounted extra machine guns in improvised positions. They modified stowage to carry more ammunition. They painted tanks with wildly different camouflage schemes based on local conditions. Official doctrine said tanks should look uniform. Crews in the field said tanks should look like they belonged in the specific terrain they were fighting in. In the Pacific Theater, Marines modified Sherman turrets to mount flamethrowers, creating the Zippo variants that could project jellied gasoline 150 yards. Navy Seabees figured out how to integrate the flamethrower into the turret to replace the main gun, rather than just bolting it on top. Nobody at headquarters ordered this. It emerged from the field because someone looked at a Sherman, looked at a flamethrower, and thought, why not both? The result was one of the most feared weapons in the island-hopping campaign. 10,000 gallons of napalm per day deployed from Sherman Zippos during the Battle of Iwo Jima. That kind of innovation doesn't come from committee meetings. It comes from mechanics and engineers who understand that the tool in front of them can be adapted to the problem they're facing. General George Patton, who had his own complicated relationship with regulation, recognized this. When he saw that the M4A3E2 jumbo assault tank, with its extra heavy armor, performed well in combat, he wanted more. The Army couldn't produce them fast enough. Patton didn't wait. He ordered his engineers to modify standard Shermans into makeshift jumbos by welding salvaged armor plates from knocked-out tanks onto 200 Shermans in his command. These field-modified tanks weren't as good as factory jumbos, but they were better than unmodified Shermans, and they were available immediately. Patton understood something that bureaucracies struggle with. Sometimes better now beats perfect later. Sometimes the enemy gives you problems that require solutions the procurement office hasn't approved yet. This creates an interesting tension. On one hand, field modifications worked. They solved real problems, they saved lives. The Cullen hedgerow cutter turned the tide in Normandy. Extra armor gave crews psychological comfort, even if the ballistic improvement was minimal. Removing governors gave tanks performance when they needed it. On the other hand, field modifications created headaches for the logistics system. Non-standard configurations meant maintenance crews couldn't assume all tanks were identical. Parts that worked on one tank might not fit another. Training documentation became outdated. The carefully constructed standardization that made American mass production possible started to fragment. From the institutional perspective, this was worrying. You can't run an army of millions with everyone modifying equipment based on personal preference. But from the combat perspective, dying by the book wasn't acceptable. And here's where we need to slow down and examine what was really happening. This wasn't just about mechanical tinkering. This was about knowledge. Tank crews and mechanics in the field possessed information that headquarters didn't have and often didn't want. They knew which modifications actually helped in combat and which were superstition. They knew when official doctrine didn't match battlefield reality. They knew the gap between what the equipment was supposed to do and what it actually could do. Headquarters had doctrine, manuals, and testing data from proving grounds. The field had evidence written in burned metal and dead friends. When a mechanic removed a governor, he wasn't just violating a regulation. He was saying, I know something the people who wrote that regulation don't know. I've seen what happens when this tank needs to move faster than the governor allows. I've done the math in blood and fire. And the equation doesn't balance unless I change this. He was asserting the primacy of battlefield reality over institutional preference. This is deeply threatening to hierarchical organizations. If sergeants can override engineering specifications based on field experience, where does it stop? If tank crews can modify equipment because they think they know better, how do you maintain any control? The answer, uncomfortable for both sides, is that you accept a degree of chaos in exchange for better outcomes. Think about what this means for the men making these decisions. A maintenance sergeant removing a governor knows he's taking responsibility. If the engine grenades itself during combat, because it was over-revved, people might die. If a superior officer catches him, he faces court-martial. But if he doesn't do it and a crew dies because they couldn't outrun trouble, he has to live with that. There's no winning choice, only the choice that seems less likely to result in dead friends. This is moral weight that doesn't appear in technical manuals. It's the burden of expertise in a system that doesn't want to hear what you know. After the war, when Army investigators compiled lessons learned, field modifications got sanitized. The Cullen Cutter became an official success story, a tale of American ingenuity. Sergeant Cullen got his medal and his moment of fame. But the thousands of other small modifications, the removed governors, the jury-rigged repairs, the technically prohibited solutions that kept tanks running, those got quietly acknowledged and just as quietly forgotten. The Army didn't want to create a precedent that field personnel could ignore regulations whenever they disagreed, but they also couldn't deny that American mechanical creativity had been a force multiplier. So they did what institutions do. They celebrated the exceptions that could be controlled while ignoring the pattern that couldn't. Let's examine the German side of this equation, because it illuminates what made the American approach different. German engineering in World War II was often brilliant. The Panther tank, when it worked, was probably the best medium tank of the war. The Tiger, despite its reputation exceeding its actual battlefield effectiveness, was a fearsome machine. German optics were superior. German long-barreled guns were superior. Individual German vehicles often outclassed individual Allied vehicles. But German engineering philosophy was fundamentally different from American philosophy. German designers optimized for performance. American designers optimized for production and maintenance. German tanks were complex machines requiring specialist knowledge to repair. Shermans were designed so that field mechanics with common tools could fix most problems. The Panther's Maybach engine, when running well, was powerful and sophisticated. It was also finicky, prone to transmission failures, and required careful maintenance. Tank crews couldn't fix many Panther problems in the field. They needed specialized parts and trained technicians. The Ford GAA, by contrast, was overbuilt and relatively simple. A mechanic with basic tools and knowledge could perform most repairs. The difference compounded over time. As the war progressed, German logistics collapsed. Spare parts became scarce. Trained mechanics became casualties or were spread too thin. Tanks broke down and couldn't be repaired. The German army in 1945 had hundreds of tanks that didn't run sitting abandoned because the system couldn't fix them. American tanks broke down too. All mechanical things break. But American tanks got fixed. The logistics tail worked. Parts arrived. And crucially, the men working on the tanks had the knowledge and confidence to keep them running, even when parts didn't arrive. They improvised. They adapted. They found workarounds. This wasn't just about having better logistics, though that helped enormously. This was about creating a culture where problem-solving was distributed throughout the organization, not concentrated in specialists. Every mechanic was empowered to think, to try to modify if that's what worked. There's an ideological dimension to this that rarely gets examined. The American approach to equipment modification reflected, perhaps unconsciously, a democratic impulse. The idea that knowledge and authority could be distributed, that the man working directly with a machine might understand its possibilities better than the engineer who designed it or the officer who authorized it. This was fundamentally egalitarian. It suggested that expertise came from experience, not just credentials, that a sergeant with grease under his fingernails might know more about keeping tanks running than a major with an engineering degree sitting in a headquarters tent. German military culture, with its emphasis on hierarchy and specialization, struggled with this concept. Knowledge flowed down from above. Decisions were made by those with authority. Field personnel were expected to implement, not innovate. Neither approach was absolutely right or wrong. The German system worked brilliantly in 1939 and 1940, when everything was going according to plan, when logistics supported the force, when specialized units could reach broken equipment. It began failing when the war became prolonged, when logistics frayed, when the gap between design specifications and battlefield reality grew too wide to ignore. The American system, with its tolerance for modification and improvisation, was messier and less elegant. But it was robust. It kept working when things went wrong. It adapted to circumstances the designers hadn't anticipated. By 1944, when the Allies were pushing into Germany from both east and west, you could see the difference. American Sherman tanks, thousands of them, kept rolling. German Panthers and Tigers, magnificent when they worked, sat abandoned by the roadside because nobody could fix them, and the trucks carrying spare parts had run out of fuel. Let's return to that mechanic in the engine compartment in the opening. Sergeant Morrison, freezing cold, hands bloody, removing a governor he wasn't supposed to touch. What was going through his mind? He knew the regulations. He'd read them. He'd signed documents saying he understood them. But he'd also pulled burned bodies from tanks that hadn't been able to maneuver fast enough. He'd listened to radio traffic of crews calling for help, while German guns repositioned. He'd done the moral calculus. The regulation existed to prevent damage to expensive equipment and maintain logistical standardization. His crews existed as people who wanted to survive the war and go home. When you frame the choice that way, when you put human life on one side of the scale and institutional preference on the other, the decision becomes clear. But it's not without cost. Every time he picked up that wrench, every time he removed another governor, he was accepting responsibility. If something went wrong, he couldn't blame the manual. He couldn't say he was following orders. He was choosing to know better, choosing to prioritize what his experience told him over what authority told him. That's a lonely position. It's the gap between being a technician who follows instructions and being a professional who exercises judgment. The Army wanted technicians. The war needed professionals. Morrison and thousands like him bridged that gap with wrenches, welding torches, and the willingness to accept the consequences if they were wrong. After the war, the Sherman got a complicated legacy. For decades, popular history treated it as the American tank that was good enough, the mass-produced workhorse that won through quantity rather than quality. The narrative positioned it as inferior to German armor, a necessary compromise that got the job done but at a cost. This narrative is emotionally satisfying. It fits the underdog story. It allows us to celebrate American industrial might while acknowledging German technical superiority. But it's incomplete. The Sherman wasn't just a good enough tank. It was an adaptable platform that reflected a broader American approach to technology and warfare. It was a machine that could be modified, that could be maintained by field personnel, that could be produced in quantities that made numerical superiority possible. Those aren't failings. Those are design features. The men who modified those tanks, who removed governors, who welded steel tusks to the front, who figured out how to mount flamethrowers in turrets, those men understood something that gets lost in discussions of specifications and armor thickness. The best weapon is the one that works when you need it, that keeps working despite damage, that can be adapted to problems you didn't anticipate. The Sherman, with a removed governor and Kulin hedgerow cutter, painted with non-regulation camouflage and carrying sandbags the manual said not to use. That tank embodied American pragmatism. It wasn't elegant, it wasn't what the designers intended, but it got home at the end of the day, which is the only specification that matters to the crew inside. Here's what rarely gets discussed. Those mechanics, those tank crews, they were engaged in a form of distributed innovation that corporations and militaries are still trying to understand today. They were doing what modern management theorists call agile development, iterating based on feedback, adapting to changing conditions, empowering those closest to the problem to develop solutions. They were doing it in 1944, in freezing mud, under fire, without the vocabulary to describe what they were doing. They were just trying not to die. But in trying not to die according to regulations, they stumbled into something profound. They proved that organizations work best when they trust the people actually doing the work to understand the work better than the people managing it. When they empower field personnel to say, "This isn't working and we need to change it." When they accept that expertise emerges from experience, not just from design offices and test ranges. The tension between the institution and the individual, between the manual and the moment, between regulation and reality. This didn't end in 1945. It's the perpetual struggle of every hierarchical organization trying to operate in unpredictable environments. The military learned some lessons from World War II. Modern doctrine emphasizes adaptability. Mission command gives subordinate units latitude to accomplish objectives using their judgment. But the impulse to standardize, to control, to ensure that every unit operates identically, that never goes away. It can't. Large organizations require standardization to function, but they also need to make space for the Sergeant Culins and Sergeant Morrisons, the people who see problems and solve them rather than waiting for permission. The Sherman tank, in its many modified and technically non-regulation forms, stands as testament to what's possible when you trust people to think, when you give them tools and training and then step back to let them work. The Ford GAA engine, with its removed governor, producing more power than Ford officially rated it for, doing so reliably because Ford engineers had overbuilt it, represents the gap between designed capability and actual capability. Between what the manufacturer thought people would do with the tool and what the tool could actually accomplish in the hands of someone who understood it deeply. Every machine has this gap. Every organization has the choice of whether to acknowledge it or pretend it doesn't exist. In the summer of 1944, as Allied tanks finally broke out of the bocage and began the race across France, thousands of Sherman tanks with removed governors and welded steel prongs rolled forward. They carried crews who knew their machines had been modified in ways that would horrify army inspectors. They also knew those modifications had kept them alive. When the war ended, when victory was declared and the tanks came home, most of those modifications got quietly undocumented. Maintenance logs didn't mention removed governors. After-action reports didn't detail the jury-rigged repairs. The Army returned to peacetime standardization, everything by the book. But the men who'd done the work, who'd made the modifications, who'd proven that sometimes the book is wrong, they remembered. They carried that knowledge forward into civilian life. They became the engineers and mechanics and managers who built post-war America. Some of them probably wondered if anyone else understood what they'd learned. That rules exist for good reasons, but survival sometimes requires breaking them. That expertise earned in the field trumps authority granted by rank. That the best tool is the one that works, regardless of what the specifications say it should do. The Sherman tank didn't win the war. No single weapon wins wars. But the Sherman, in all its modified, improvised, technically non-regulation glory, represented something important about the American way of war. Not just industrial capacity, though that mattered. Not just technological innovation, though that helped. The Sherman represented trust. Trust that the men using the equipment understood the equipment. Trust that field modifications emerged from necessity, not carelessness. Trust that a sergeant with a welding torch might solve a problem faster than a committee of engineers. That trust extended downward through the ranks, multiplied American combat effectiveness in ways that don't appear in production statistics or armor penetration tables. It's impossible to quantify. But everyone who served knew it was real. Sergeant Morrison, hands bloody and freezing, tightening the last bolt on the engine access panel, had no idea he was part of a larger pattern. He was just trying to give his crew the best chance of surviving the next engagement. The governor was in his pocket. The engine would run free tomorrow when they rolled out. If anyone asked, he'd deny everything. But he knew, and his crew knew, and probably the company commander knew even if he'd never acknowledge it, that this tank was now faster, more responsive, better suited to the chaos they'd face. It wasn't regulation, it was right. Sometimes those aren't the same thing. Recognizing the difference and having the courage to act on it, that's what separates technicians from professionals, subordinates from leaders, following orders from winning wars. The Sherman tank, that supposedly inferior machine that somehow helped win the greatest conflict in human history, succeeded, not despite the modifications, but because of them. Because the American military, for all its bureaucracy and regulations, left just enough space for the Sergeant Morrisons to pick up their wrenches and do what needed to be done. That space, that tolerance for improvisation, that willingness to look the other way when field personnel knew better than headquarters, that might have been America's secret weapon all along.